This video shows the procedures and instruments used in the Anthropometry and Body Composition Laboratory, ABC Lab, of the Department of Life and Environmental Sciences of the University of Cagliari. In accordance with the ethical principles of the Declaration of Helsinki, each volunteer or their guardian must give their informed consent to participate in the measurements. For this purpose, the volunteer should be given a document a few days before the visit, containing the essential information about the measurements to be taken and the results that may be obtained. The rules to be followed prior to testing should also be communicated. Avoidance of food or water for the previous 4 hours, alcohol for at least 48 hours, and strenuous exercise for at least 8 hours. The skin must not have been treated with moisturizing creams, oils, or similar products. Further information will be provided on the day of testing. The instruments for measurements must be professional. An anthropometer, consisting of a graduated rod and a sliding bar, is required to measure stature. A mechanical scale is required to measure weight, and a metric tape is required to measure lengths and circumferences. In the ABC lab, impedance measurements are made using a single-frequency impedance device that produces a low-intensity, constant-frequency current, 400 microampere and 50 kilohertz, through tetrapolar insulated cables connected by red, injector, and black, sensor, alligator clips to electrodes placed on the subject's skin. At the beginning of each measurement day, all equipment must be checked to ensure that it is working correctly. Calibration of the anthropometer is performed by ensuring that the vertical rod is perpendicular to the ground using a square or spirit level. The scale is calibrated by adjusting the 0 point and periodically adding objects of known weight. The impedance device is calibrated using a tester that electrically simulates the human body. The tester is connected to the instrument, and a check is made to ensure that the measured value corresponds to the indicated value. For the instrument used at ABC Lab, the permissible range of variability is 10 ohms for R and 85 ohms for XC. It is also necessary to ensure that the alligator clips on each cable are clean, that is, free of gel residue from the electrodes, and to check the state of wear of the spring. The cables and clips should also be calibrated. Finally, the electrodes should be stored in a sealed bag away from heat sources, and the integrity of the gel should be checked when applied to the body. Signed informed consent will be obtained and further clarification provided prior to the start of the measurement. The survey can then be started. Prior to the start of the measurement, the previously distributed and signed informed consent document must be obtained and any further clarification provided. The operator and the document should state the guarantee of confidentiality of the data and emphasize that consent to the measurements can be withdrawn at any time without justification and without consequences. The survey form can then be filled in with the personal data: first and last name, which will then be anonymized, date of birth, place of birth, sex, gender, email. The form also includes a notes section where operators can note acute or chronic illnesses, the presence of prostheses, or other observations useful for analysis. A final section of the sheet lists all the anthropometric and impedance variables whose numerical values are recorded and transcribed during the measurements. The volunteer is then invited to enter a private room where she can wear clothing appropriate for the measurements and is reminded to remove any metal objects, such as jewelry and watches, as these can interfere with the measurements. Finally, it is important that the volunteer has emptied his or her bladder before starting the test. During the measurements, the surveyor will endeavour to behave in a professional, courteous and respectful manner, trying to limit close contact as much as possible. For whole-body BIA, anthropometric measurements are taken on the right side. That is the same side where impedance measurements are taken. However, if the BIA protocol includes segmental measurements on both sides of the body, Anthropometric measurements should also be taken on both sides. To measure stature, the volunteer is asked to stand with his/her back to the anthropometer rod, with the heels together against the base of the rod, and the toes spread about 60 degrees apart. The arms are extended at the sides of the trunk with the palms facing the thighs. The head must be aligned with the Frankfurt horizontal plane, that is, with the lower edge of the orbit horizontally aligned with the upper edge of the acoustic meatus. The operator checks that the subject is in the correct position and asks for a deep inhalation followed by an exhalation. He then stands to the side of the instrument and slides the movable bar of the anthropometer until it touches the highest point of the head, applying just enough light pressure to compress the hair. Weight is measured using a scale. The volunteer is asked to stand in the center of the platform and distribute the weight evenly on the legs. The operator stands behind the scale, facing the subject, and reads the display in a vertical position to avoid parallax errors. Lengths and circumferences are then measured using metric tape. For arm circumference, the first step is to identify the midpoint between the shoulder and the elbow. The operator asks the volunteer to bend the arm at a 90 degrees angle and measures the distance between the proximal point and the distal point from a lateral position, taking care to ensure that the tape measure runs vertically without bending. The midpoint can then be calculated by dividing the measured length by 2 and marking the point on the arm with a pencil. The operator asks the volunteer to stretch the arm again, keeping the muscles relaxed. Taking care not to compress the tissue and keeping the tape measure horizontal, the measure of the circumference of the arm can be measured at the midpoint. For segmental impedance analysis, the length of the upper limb must also be measured. The operator measures the distance between the proximal and distal points, ensuring that the metric tape is vertical without bending. The waist circumference is also measured with the volunteer in an upright position. The subject is asked to expose the abdomen by lifting part of the t-shirt and crossing the arms over the chest. The operator finds the narrowest point and places the tape there, checking, sideways, anteriorly and posteriorly, that it is parallel to the ground, then takes the measurement at the end of a normal breath. To measure the calf circumference, the operator asks the volunteer to stand on an anthropometric cube and remain in an upright position, with arms outstretched at the sides and hands pointing towards the thighs, legs slightly apart, and body weight evenly distributed on the two sides. Then places the metric tape around the calf, sliding it up and down until the maximum circumference is reached. After checking that the tape is horizontal and asking the subject to keep the calf muscle relaxed, the measurement can be taken without compressing the tissue. For segmental impedance measurements, the length of the lower limb must also be measured. If the trochanter is difficult to locate by palpation, the subject may be asked to abduct the limb to be measured in order to identify the anatomical point. The operator measures the distance between the proximal point on the trochanter and the distal point on the lateral malleolus, ensuring that the metric tape is vertical. The subject is asked to lie on the couch in a supine position. During the measurement, the arms should be at an angle of about 30 degrees from the trunk, and the legs should be at an angle of about 45 degrees from each other. The subject should remain in this position for 5-10 minutes to reduce interference from physiological changes. Electrodes may be applied during this time after cleaning the skin with alcohol. Their correct positioning is very important. If the analysis covers the whole body, electrodes are placed on the front of the hand and foot. On the hand, one electrode is placed distally between the second and third metacarpals, while the other is placed on the wrist at a distance of at least 5 centimeters from the first. On the foot, one electrode is placed between the second and third metatarsal and the other on the anterior surface of the ankle. Once the electrodes are in place, the alligator clips can be connected. The cables must be fully unwound to avoid self-induction effects, and handled with care to avoid damaging the internal strands. The red clips are placed on the distal electrodes and the black clips on the proximal electrodes. The impedance device is then switched on, causing a low-frequency alternating current, imperceptible to the subject, to be transmitted transcutaneously through the body tissues. In a few seconds, the display will show the resistance and reactance values. At the end of the measurement, in this and all subsequent cases, the impedance device is switched off. In the case of segmental BIA, that is when the analysis involves the limbs and trunk, several alternatives for electrode placement have been proposed in the literature. In the ABC laboratory, a procedure is used that is the result of a reasoned synthesis of the different approaches proposed. In the upper limb, the position of the electrodes on the hand is the same as in whole-body BIA, while on the shoulder, one electrode is placed at the level of the acromion and another 5 centimeters away next to the axillary line. For measurement, the red alligator clips are connected to the most distant electrodes. At shoulder level, the red clip should be placed on the acromial electrode and the black clip on the axillary electrode, while at hand level the clips are positioned as for the whole-body BIA, that is the red clip distal to the metacarpal electrode and the black clip proximal to the wrist electrode. The impedance device can then be switched on again and the resistance and reactance values measured and recorded. In the lower limb, the position of the electrodes on the foot is the same as in whole-body BIA, while in the proximal pair, one electrode is placed at the level of the iliac crest and the other 5 centimeters distally towards the midline of the thigh. Those on the pelvis must be placed with the red clip on the iliac crest electrode and the black clip on the thigh electrode. The alligator clips on the foot are connected as in the whole-body BIA, red clip on the metatarsal electrode, black clip on the ankle. The impedance device can then be switched on again and the resistance and reactance values measured and recorded. Electrodes placed on the shoulder and pelvis are used to measure the body composition of the trunk. To do this, the position of the 2 alligator clips at pelvic level must be reversed, that is the red clip on the thigh and the black clip on the iliac crest, and the other 2 clips at shoulder level must be connected, red clip at acromion level, black clip on the axillary electrode. The device can then be switched on again and the resistance and reactance values recorded. The trunk length is approximated by the distance between the outer edges of the most distant electrodes. If the analysis includes measuring the contralateral side, the limb measurements are repeated on the left side, but not the trunk measurement. All electrodes are removed at the end of the measurements.